Properties of systems and their solutions. So this is our third lesson. I taught 2 to you guys in class, 1 and 2, and this is the third one. So it says, there is one final way that we will solve systems of equations, but we won't look at it until the next lesson. This lesson is going to kind of lead up to it. It says systems are important because they tell us multiple conditions that relate multiple variables or unknowns, meaning in all of these cases we'll have 2 equations with 2 unknowns or 2 variables. Okay, so it says we'll experiment with systems and what we can do with them and how this affects their solutions. So let's consider the solution 1, 5, and we've got this system of equations here to the right. It says show that x equals 1 and y equals 5 is a solution to the system. So that's where we start and we do our substitution. So we say 4 times 1 plus 2 times 5, does it equal 14? We're going to check to see if that's true. And that's 4 plus 10. So 4 plus 10 is certainly 14. And then the next one, checking that same point into this second equation, 1 minus 5, does that equal -4? And that is also true. So 1, 5 is a solution to this system of equations, meaning if we graphed these 2 equations and found where they intersected, they would intersect at 1, 5. Now let's play around with these 2 equations. It says find the sum of the 2 equations. So if we were to sum these 2 equations up here, we've got to combine like terms. So we have, sorry, I have to pause. My dog's walking around with one of my Christmas decorations. Sorry about that. Okay, so it says find the sum of the 2 equations. So let's take these 2 equations and let's combine like terms. So I'm just going to rewrite, and we're going to combine the x's with the x's, the y's with the y's, and the constants with the constants. So if I were to do sort of an old-fashioned addition problem here, I know that this is 5x, and then when I combine this, I get a positive 1y, and I get 10 here. So we have this new equation, and it says, is 1, 5 a solution to this new equation here? So let's do the same thing. So let's check and see. So we do 5 times 1 plus 5, does it equal 10? So yes, that is true. So our point 1, 5 is a solution to that new equation. Now we're going to continue to play with those same 2 equations. They're going to ask us to multiply both sides of the second equation by 2. Now he's chewing Snickers. Louis. Let's see if I can get him to speak. Louis, speak. Louis, speak. So that's Louis. Can you speak again? Speak. Okay, sit down. All right. So, sorry, getting off track here, wasting time. So we're going to multiply both sides of the second equation by 2. So that second equation is x minus y. Oops. X minus y equals -4. And we want to multiply that second equation all by 2. Okay? So we end up with 2x minus 2y, we're just using the distributive property here, equals -8. And they want to see, is 1, 5 a solution to that new equation? So again, we do the same thing. 2 times 1 minus 2 times 5. Does that equal -8? So we end up with -8 equals -8, and that is absolutely true. So 1, 5 is a solution to this new equation. Okay. So what have we done so far? We've added 2 equations together. We've multiplied an equation by a constant. Now it says, and that 1, 5 still works. So it says, take the equation you found in C and add it to the first equation. So the equation that we just came up with in C is this. And then add it to the first equation. So our first equation was 4x plus 2y equals 14. 4x plus 2y equals 14. And they're saying, what happens? So again, combining like terms, we end up with 6x, -2y plus 2y. Those go to 0. equals 6. And it says, what happens? Well, the y's, okay, went to 0, right? We ended up getting rid of a variable. Went to 0. Okay. How does this allow us to now solve for the variable of x? So we've got x, we can get x all by itself. We divide by 6, and we get x equals 1. Okay, so isn't that what's been happening all along? X has been 1, right? Well, let's see. It says once you know the value of x, how can you find the value of y? So you can take that value of x that we found and plug it into, now he's running around my scarf. He is the worst. He's got so much, he's like the attention-seeking behavior dog right now. Okay, so we've got x, now let's find y. So you can take this x and obviously plug it into any one of the equations that we've come up with today to find y. So I would say be safe and always go back to one of your originals. So looking at our two originals, this one's probably the simplest to work with. The second one, x minus y equals that -4. So x minus y equals -4. Well, we know what x is. It's 1 minus y equals -4. So take this equation. It's just a simple two-step equation that we can solve for y. So -y equals -5. We divide by -1 to get y by itself, and we end up with y is +5. Okay. So now obviously what was happening there with all those equations wasn't coincidence. Okay, so let's go ahead and flip the page. It says, so what we see is that a solution to a system of equations remains a solution to that system under a variety of conditions. So solutions to systems remain solutions if. Okay. So properties of equality are used to rewrite either of those equations. Properties of equality. Okay? Or the equations are added or subtracted, or any rewrite is added or subtracted. So our properties of equality mean we can multiply by a constant, we could divide by a constant, and then they're also saying that we could add or subtract the two equations, or any rewrite we could add or subtract, and those solutions will remain the same. So let's play some more with these ideas, but with a new system. So we've got two new equations here, and it says show that 3, -1 is the solution. So 4 times 3 minus 3 times -1, does that equal 15? We get 12 plus 3 is 15. Yep, that's true. But in order for it to be a solution to the system, it has to be true for both. Does that equal 7? So we get 9. Did I write something wrong? I did. Plus. There we go. So 9 minus 2, that's 7. Okay, so that's true. So it definitely is a solution. So now it says the 0.31 will be a solution to the system shown below. It's telling us that it is a solution. How can you determine this without substituting the point in? So let's compare the original, okay, these two equations. And now what kind of pattern do you see from this first equation to this second equation? And then what might you see from this second equation to this new second equation? They must somehow be related to each other if they're saying that 3, -1 is also a solution to this system. So again, compare first equation to first equation, second equation to second equation. So what do you see that's going on there? So hopefully you were able to see that comparing the first equations, okay, this is just a multiple of 2 to this first one. If you took and multiplied this whole first equation by 2, you'd get this equation. Okay, so the first equation, multiplied by 2. Okay, that's a property of equality. Okay, we multiplied that whole equation, so that's an equivalent equation. So now, what about this second equation compared to the original second? Hopefully you were able to see the second is multiplied by 3. Again, using that property of equality of multiplication, as long as you do it to the whole equation, you're not changing the equation. You're changing the way it looks, but it's still equal. So it says, what happens when you add these two equations together? So now let's take those two new equations and add them together. So I'm going to take them and add them together. So we get 17x. Oh, look at that. The y's cancel out, or go to 0, I should say. And we get 51. So now x is equal to 3. Okay, so it says what happens, the y's go to 0. And that's what we need, because we can only solve an equation with one variable. So we have to eliminate one of the variables. So it says, how can this let you solve for x? Oh my gosh, could there be more distractions today? Okay, so the y's go to 0, so we found x, now we've got to find, it says find it and find y. So remember what we said, we got one of the variables, we take that solution and plug it into one of the original equations to find the variable that we eliminated. So I'm going to go back up to that first equation, okay, the first original. Always go back to the originals, and we're going to substitute in that 3, so therefore we can find the y. So we end up with 12 minus 3y equals 15. For the sake of space, we're going to subtract 12 from both sides and get 3, and we end up with y is equal to -1. So there is our solution, 3, -1. It says solve the system below using the method of elimination. That's just what we've been doing. Show the steps in your work and show that your answer is in fact the solution. So in other words, we've got to do the substitution in the end. So we've got this. So in order for us to be able to solve this, we've got to eliminate one of the variables. So when I look at this, because in order to eliminate, I've got to use that property of equality. So I'm going to have to multiply one or both of the equations so that I end up with opposites over each other. Because when I look back up here, I ended up with opposites, -6y plus 6y. That's what I need to be able to happen. So when I examine these x's and these y's, I say to myself, I probably could multiply this equation by a -3, because then what happens? So when I distribute, that -3, I end up with, oh, for the love of Pete, that was Mr. Swinson the first 2 times. Oh, and it's not Mr. Swinson this time. All right, solicitor, I just hung up on. So this is just entertaining for you guys, I'm hoping. I hope you're not irritated with it. -12y equals -6. So I've got this new looking equation, and now I don't need to do anything to that second equation. And now when I go to add them, my x's eliminate, which that's what I need, because now I can find one of those variables, -9y equals -9, and y is equal to a +1. Now if we have one solution, we've got to be able to take and substitute back into one of the originals. I'm going to go back into the first original. Now we solved for y here, so make sure you're putting it in for y and not for x. We need to find x. So 2x plus 4 equals 2. 2x equals -2, and x equals -1. So my solution is -1, 1, and they want to check that. So I end up saying 2 times -1 plus 4 times 1. Does that equal 2? So, yep, -2 plus 4 equals 2. That's true. And now take that solution again and plug it into the second equation. 6 times -1 plus 3 times 1 equals -3. So -6 plus 3 is -3. That is absolutely true. All right, nice job, guys. We're going to practice this a lot in the next couple lessons. Oh, and there's the phone again.